Dear students, welcome to my YouTube channel Elite Maths Class. In this video, I will discuss product of two determinants and operation on a determinant. Product of two determinants, it is also an operation, and operation on a determinant, this is some particular case. I am coming to that part later. Now see how to product two determinants. In the properties of the determinant, that is in my second video, I already discussed some properties. In that properties, one property was there, how to find or how to split a determinant. It is also called addition of two determinant or summation of two determinants. Here we will see summation or difference is same. Here we will see product of two determinants. Here one thing, when two determinant are to be multiplied, this is the question, that is when we can multiply two determinants. The answer is when two determinants are of same order. In my previous videos, these are already discussed orders. Now order of determinants are, say del is a determinant of order 2 by 2 and del, another del, say it is what to give the name, say it is del prime. Del prime is another determinant, is of order 3 by 3. Then we cannot multiply or we cannot find the product of these two determinants. So the determinants, product of two determinants, is only possible when they are of same order. That is, two determinants of same order can be multiplied. Two determinants of same order can be multiplied. Let us first see that rule. Then in the next part, in some particular cases, in some special cases, we can multiply determinants of different order also. So let us first how to find the product of two determinants of same order. Let us first see the simple one, that is of order 2. Let say a1 b1 a2 b2 and another determinant, say it is x1 y1 x2 y2. Clearly this is two determinants of same order. It is a determinant of order 2, it is a determinant of order 2. Now how to find the product? Remember one thing, their resultant will be a determinant and that will be of same order. That is, by multiplication of two determinants of order 2, the resultant will be a determinant of order 2 again. Now see the product process. Here the rule is, see in the first row there are two elements, here two elements, two elements. So we have to multiply these first row, elements of first row to the elements of first row of the second determinant. Corresponding elements will be product and then sum. Then in the second step we have to do this. Now see these two operation. That is, first thing we have to do, first row into first row, corresponding elements product, then sum. So here the first element is a1, here the first element is x1, so it will be a1 x1, then plus, then second element b1 y1. Then the next operation is first row second row, row into row, a1, here it is x2, so it will be a1 x2 plus b1 y2 b1 y2. Then we have to consider second row into first row of the second determinant. So see here what we are getting, first element is a2, here it is x1, so it will be a2 x1 plus b2 y1 then the operation of second row first row complete, then second row a2 x2 plus b2 y2 for easily so that you can easily memorize. You memorize this technique, summation of row into row. Summation means plus row into row, that is first row product of the corresponding elements, then sum, then row into row, then row into row, then row into row. So this is the technique in which you can easily memorize the process how to find the product of two determinants of order 2 by 2. In the same way we can find the product of two determinants of order 3. Now let us see the product of two determinants of order 3. As these two are determinants of order 3, see 3 row 3 column, the process is same as that of order 2 by 2. Order 2, the process is same, that is we have to multiply the corresponding elements, then we have to add them, that is summation of corresponding elements of first row with first row, then first row with second row, first row with third row. So see, as in the previous case, as in the case of order 2, first thing here what we have to do, first row into first row, first row into second row, first row into third row. Now see this, a1 first element a1 x1 plus second element b1 y1 plus c1 z1. Next this will be the whole first row, then first row into second row, a1 x2 plus b1 y2 plus c1 z2. Now first row third row, a1 x3 plus c b1 y3 plus c1 z3. So operation by first row is finished. Now start with second row. Again here we have to do the same thing, second row first row, second row second row, second row third row. So now see, second row with first row, a2 x1 plus b2 y1 plus c2 z1. Next second row, it is a2 x2 plus b2 y2 plus c2 z2. Now second row third row, here it is a2 x3 plus b2 y3 plus c2 z3. Clear? Now one row left, third row in the same process, third row first row. So we are getting a3 x1 plus b3 y1 plus c3 z1. First row finished. Now first row second row, it will be a3 x2 plus b3 y2 plus c3 z2. Then third, it will be a3 x3 plus b3 y3 plus c3 z3. Here also the same technique, summation of row into row. This is the technique how easily you can memorize the process of multiplication of two determinants. First row, that is r1 into r1 corresponding r1, then sum, then r1 into r2, then r1 into r3. This is the first determinant, second determinant. These are the first three elements of the first row of the resultant determinant. So here we are having also a 3 by 3 determinant. This is also a 3 by 3 determinant. This is the process of multiplication of two determinants of order 3. Actually process is same, but here we are getting a 3 by 3 determinant. Here one thing you remember, that here the operation is done with row, then adding the elements, then here we are writing along the row, but here you can write these elements, that is this first row, you can write along first column. As in the properties we have already seen that if the rows and columns of a determinant are interchanged, then the values is unaltered. In that case, by this property you may write this whole row in the first column, this second row, that is the resulting operation by first two, you may write in the first column, that is first you write first column, then by r2 you write in the second column, then by r3 you write in the third column. Total resulting value will be same. So this is the product of two determinants. Now let us see how, when two determinants, in a particular case when two determinants are of different order, we can find the product. As an example, let us see how to find the product of two determinants of order 2 and another of order 3. Actually this is out of your board syllabus. In your board syllabus this type of product are not necessary. So here we are to find product of a determinant a1 b1 c1, a2 b2 c2, A3 B3 C3. This is a determinant of order 3 and a determinant of order 2, say x1 y1 x2 y2. Clearly it is a determinant of order 3 by 3. It is a determinant of order 3. Now how to find the product of this determinant? This is a special case of finding product of two determinants. Now see here what we have to do, or what more modification we have to make. Which one is of larger order? 3 by 3. So let it unchanged, that is whatever it is given, a1 b1 c1, a2 b2 c2, a3 b3 c3. No change in the bigger determinant or in the determinant which is of greater order. Now as this determinant is of order 2 by 2 and two determinants of different order cannot be multiplied, so what we have to do here, see this step. Here you have to write one row and one column like this. This element is 1 and all other elements are 0. Then write whatever determinant it is given here, x1 y1 x2 y2, and now see that these two determinants are of same order. It is a 3 by 3. It is also a determinant of order 3. So this is the technique, this is the conversion we have to make. Which determinant is of smaller order, we have to convert it into a determinant of the larger determinant of same order. So this is the process how you can convert this 2 by 2 determinant into a 3 by 3 determinant to find the product. Then the rest of the product procedure is same as the previous one for the rule of the product of two 3 by 3 determinants. So this is clear. In the next part, let us see what is operation or what type of operation we can apply on a determinant of any order. Now see what is operation or what type of operation we can apply on a determinant. For example, let us take a 3 by 3 determinant. So it is a1 b1 c1, a2 b2 c2, a3 b3 c3. We can apply the same operation on a determinant of order 2 by 2 or of higher orders, which is not included in your syllabus. Now what operation means on a determinant? Operations means here we have to apply some process, some techniques on the given determinant by a particular way that I am coming. In that particular way, if we apply some operations, some you may say some techniques, some addition, subtraction by using some particular way, after application of this type of operation on a given determinant, the value of the determinant is unaltered. This is the most important thing. After applying some operations or any number of operations, the value of the determinant remains unaltered, subject to the condition we have to apply the operation in a proper way. If you do any mistakes, then the value of the result will be changed. But the property is that these operations, if we follow these operations, the value of the determinant will remain unaltered. Now what are these operations or which type of operation we can apply? See, this is the given determinant. Operations means there are of two types of operations. Operations means one is row operation and another one is column operation. This type of operation are there, and these two at a time, these are called elementary operation, which is very useful in a matrix. In my matrix classes, I will discuss the importance of this elementary operation, that is row operation, column operation. Here just see what are operations, how operations can be done, or what precautions we have to take before selecting the operations. Now this is the given determinant, so this one is first row, second row, third row. this is first column, second column, third column. Now the operation technique is, we can change any one of the row, that is the, you can change first row, you can change second row, you can change third column, you can change the second column, any one by row operation. Whenever you have to change row operation or you want to change any one of the row, then we have to apply row operation. If you want to change any column, then it will be column operation. Now for example, say I want to change the first row, that is, this is old row. Now why we want to make some changes in the first row, that is, we want to make a new row. So it is named as R prime, that is first row, sorry, R1 prime, that is first row, first new row. That is, this will indicate the first row in the next determinant, which is obtained from this determinant. Say the operation is R1 minus R2. This is the simple one, R1 minus R2, that is, R1 means here R1 and R2 means the old R1, R2, R3. In every step, if you writing R1 dash means the first row of the second, that is the determinant of the next step, and R1, R2 means the first row, second row of the previous step. So here R1 minus R2 will be obtained by R1, this one R1, this one is R2. So this value will be obtained by subtraction of the corresponding elements, that is, the resultant will be, see here I am writing, by applying this, what we are getting, we will be getting A1 minus A2, B1 minus B2, C1 minus C2. See the elements of first row subtracted, subtraction elements of second row. No change in the second row, third row. So second row, third row will be unchanged. A2, B2, C3, sorry, A2, B2, C2, A3, B3, C3. Clear? R1 means the old first row, R2 means old second row, then R1 minus R2 means first row, whole row minus whole row, that is subtraction of the corresponding elements. Then what type of more operation we can apply? Say R1 dash equal to, it may be R1 plus R2 plus R3. More operation I am writing, just see the similarity. Say R1 dash equal to R1 minus R2 by 2, R1 minus R2 plus R3 by 2, R1 minus 3R1 by 2 plus 5R2 by 3, etc. Now see these 5 operations I have written randomly. This one is the first one. See this one. See this one, this one, this one, this one. What is the similarity? See all the relations starting with R1. This is the technique. What row or which row or column you are changing, you want to make the operation, that operation will start with that row or column only. Here I have shown the operation on first row. See every relation, every operation starting with R1 only. After that you can do anything, you can use any two row in any way except the first row. First row, as we are changing first row R1, then R1 will be used once. R1 plus or minus, here plus minus, you may use plus here, you may use plus here, whatever operation you do by the remaining two rows, but the first element of the every operation will be same. This is the technique, and this technique is also same for columns. If you want to apply some column operations, C1 minus C2, C2 dash minus C2 plus C3, whatever operation you can you want to apply, then you can subject to the condition. This is the technique, that is, which row or column you are applying some operation, in which row or column, or which any row or column you want to change, that operation must start with this one only. Say for example, if you want to change, say R3, then R3 will be here, R3 cannot be in the remaining elements. Say for example R3 plus R2, it may be minus 2 R1. So see this, as we are changing R3, the operation started with R3. This is the technique. In this way you can apply any number of operations any number of times, but the total value of the determinant will be unchanged or unaltered, and especially these operations are also useful in matrices. So hope these are clear. Operations, product of two matrices, and product of two matrices of different order also shown. This is a very important or particular technique. So these are the things, and in my next video I will discuss some application of determinants, and that will be the last part of the theoretical part of the determinants. Then I will show you different types of determinants which can be solved by this type of operations, some applications. Hope this was very helpful. Thank you very much.